Hi guys, and welcome to lesson 7.6, Growth and Decay. So we talked about in class about how exponential equations, there's the graphing part and then there's the equations part. Today we're going to get into some solving equations and working on dealing with the exponential equations themselves. Now, as I mentioned in class, exponential growth is when something increases extremely rapidly. So debt, the amount of money you owe people, sales, how many units of phones or games get sold, all of those increase rapidly. And here are some other examples. Bacteria growth. You start off with one piece of bacteria and then all of a sudden you have millions. Watch your nearest cleaning commercial for examples of that. Exponential energy or nuclear explosions, energy increases. All of these are examples of something that started out small and then got really, really big, really, really quick. Now, the equation for exponential functions, if you remember from the other day, is y, okay, it's y is equal to a times the base to the power of x. Okay, this is the general equation for exponential functions. You'll notice that we're still using the basic structure of the equation. We're just expanding a bit on what the base is. Okay, so the base now has some stuff inside. When you come down here, these letters all mean something. So A is the initial amount. Okay, before anything can grow really, really rapidly, it had to start out as something. Then you have plus 1. R is the rate of change expressed as a decimal. So how fast is it growing? T is time, and then Y is our final amount. Okay, you really need to have this equation memorized. We'll be using it a lot. Starting now. So let's go over this one. The prize for a radio station contest begins with a $100 gift card. Once a day, a name is announced. A person has 15 minutes to call or the prize increases by 2.5% for the next day. Write an equation to represent the amount of the gift card in dollars after T days with no winner. Okay, so I underlined the things that we needed. Now I'm going to go back and label them. Begins. $100 is our starting amount. That's going to be A. Okay, next we have 15 minutes. Okay, 15 minutes is time. That's going to be T. And then last but not least, 2-point increases. Here's how we know it's exponential growth. It's increasing. This is going to be our R, our rate. As a reminder, our general equation is y is equal to A, 1 plus R to the power of T. Okay. Now, our question asks us to first write an equation to represent the amount of gift card in dollars after T days with no winner. T days means that it doesn't want you to solve the equation, it just wants you to write it using the information given to you in the problem. So here we go. I've already labeled everything, so this will be easy. You just got to plug everything in. Y is going to stay there because Y would be our final amount, and we don't have that yet. Equals A is 100, 1 plus R. R, remember, R has to be a decimal. So that means we have 2.5%. I'm going to carry my decimal place over, 1, 2. And the decimal of R equals 0.025. So 0.025. If you've forgotten how to turn decimals or percentages into decimals, talk to me during office hours or before class. We need to review that. Next, they want T days with no winners. Okay, now when we go back and look at our problem, we have labeled that 15 minutes is T. However, when we read the question, it says the person has 15 minutes to call or the prize increases by a rate of 2.5% for the next day. So 2.5% applies to the day, not the minutes. Which means that this information in the 15 minutes was simply put there to trick us and confuse us. We don't need it. Okay, T refers to days, not minutes. So when I go down into my equation down here, I'm going to put a T because we already have the correct rate in here. All right, now that I have my equation, I need to simplify the inside of the parentheses. So I have y is equal to 100, 1.025 t. And this is my equation. When I go down to B, this is where things get interesting and I get to solve. So this one asks for how much will the gift card be worth if no one wins after 10 days. Here is T. Okay, so I'm going to take my equation from part A and just plug in T. Y is equal to 100, 1.025 to the power of 10. When we solve for this, we get that y is equal to 128.008. Okay? And since we're dealing with money and money only has 2 decimal places, we'll round to those first 2. So that means that y is equal, or y is about $128. You guys try this one. The video will pause, and then when it plays again, you'll see my equation and the answer to the second problem. All right, and here are my answers. So for just writing the equation, when I read the problem, I saw that the rate was 5% and that the initial price was $10,850. And you can see my equation right here. Now, I did still write it in 2 separate steps. So the original, unsimplified parentheses and then the simplified parentheses. It's always a good idea to remember that 1 is right there, because when we get to exponential decay, something else happens, and I want you to remember that 1 does exist right there. Okay. Then in the next part of the question, we wanted to know what the cost of college was in 2020. So you subtract 2020 from your original year of 2000 and get 20 years. Plug it all in, and that is the number you get. On a completely separate note, I have no idea if this is true. I'll let you guys do that research. Now, exponential decay. If things can increase rapidly, things can also decrease rapidly. So in tournaments, the number of players decreases rapidly. As you get further away from music, the sound and the frequency decreases rapidly. Earthquakes, the further you get from the center of the earthquake, the less energy there is. That decreases rapidly. You guys get the picture. Now, exponential decay is the amount in which we decrease at the same percent over a period of time. This same percent bit is the important part. Okay, because there is a way we can change how fast something decreases, but we're not talking about that here. This equation is implying a constant rate of decay. Now, as you look at the equation down here, you can see that we're using all the same letters. 2 big differences, though. Number 1, we are subtracting now, which makes sense. I mean, we're decaying. Reason number 2, or thing number 2 that's different, R. Beforehand, we had no limit on what R could be. Now we do. R has to be in between 0 and 1. All right, it has to be a decimal in between 0 and 1. Here we go. So the population of Campbell County, Kentucky has been decreasing. Here's your tip-off that we're doing exponential decreasing, or exponential decay, at an average rate of about 0.3% per year. This is the other thing that's important. It tells you that the decrease is constant. In 2000, its population was 88,647. Write an equation to represent the population if we're looking at 2010. Okay, so let's label. Okay, this is our R. As we write it in a decimal format, we have 0.03. Whoops. No, we don't. We have 0.003, which is a decimal in between 0 and 1, so that criteria checks off. Next, this is A, And here 2010 is our years. So 2010 minus 2000, t is going to be 10 years. All right, now let's write our equation. It's always a good habit to write the general equation first. That way you don't forget where your pieces are, specifically that subtraction symbol. Okay, now let's plug in. Y is equal to 88,647 times 1 minus 0.003 to the power of 10. Next, we simplify. I'm simplifying inside the parentheses first, and then I'll do my exponent, because we have to simplify inside the parentheses first. Now, I know it's very easy to plug all this into the calculator and just do it in one fell swoop. However, it's a lot harder to find your mistakes that way. So do it in the 3 steps. Simplify inside the parentheses first, and then plug it all in the calculator. And you get that y is equal to 86023.206. We can go ahead and round to the second decimal place. And this is our answer. Now, kind of flashback, compound interest. You'll hear this a lot, especially if you take a finance class. Compound interest is probably the most prevalent example of exponential increase or exponential growth that you'll see. All right, it's an application of exponential growth. Compound interest is when interest is earned or paid. This makes the rate at which things grow change. Okay, and you can actually see that down here in our equation. So mostly we have the same letters. We did change A. A is now Y, and it is now the current amount. So the amount you currently have. P, so this position at least, is still the initial amount, but now it's letter P. We're adding because we're increasing. This is growth. And next we have this weird little fraction. So instead of just rate, we have rate, so R, and N. N is the number of times interest compounds each year. So the number of times you add on. An example of this is, say you put money in the bank, you put $10 in the bank, and it increases at $1 per year. Okay, or $1 per month. Okay, so after a month, you now have $11. After 2 months, you have $12, and so on. Compound interest says you go in and you add $5 every single month as well. So if you originally have $10, and then it increases by $1, well, now you're adding $5 as well. So that first month, you don't have $11, you have a full 16. And it's going to keep adding on. That second month, so we have 16, instead of just adding one more, you're coming in with your extra 5, and now you have a full 22. Okay? This equation expresses a more advanced version of that. And before we move on, I want to point out one thing. N is the number of times the interest is compounded each year. Okay, so if you compound, as in my example, monthly, that means you're compounding 12 times a year. So N would be 12. Okay, T is years. T can no longer be anything except for years in compound interest. And N. Let's practice. So we want to determine the amount of an investment. If 300 is invested at an interest rate of 3.5% compounded monthly for 22 years. So now let's label. This is P, my initial amount. This is still R, my rate. And I got to turn it into a decimal, so 1, 2, which means my rate is 0.035. Compounded monthly, here's my N. N is 12. We've compounded this monthly for T, 22 years. All right, so always, like I said, write out the initial equation just so that you know where you're starting from and you don't forget that you've changed equations or anything. It's also a good way to catch mistakes because that should be r over n. If you write it out, it's easier to catch those things. Now let's plug in. A is equal to 300, 1 plus 0.035 over 12. Then we have 22 times 12. Now, normally I would say simplify inside the parentheses first. However, that number is going to be a really large decimal. In this case, just go ahead and plug it all into the calculator and click enter. But be very, very careful that you don't make a typo error. Okay, when you plug everything into the calculator, it's a lot harder to find your math mistakes because they're buried in calculator mistakes. So when you plug this in, pay special attention and make sure your formatting is correct. Okay, if you don't know how to put a fraction in the calculator, you need to ask me because we got to figure this out by now. You should have gotten that A is equal to 647.2. If you did not get this, go back and check your calculator for any errors. Okay, a common one is to put a plus sign in your exponents instead of multiplying those two numbers. All right, this is the end of the video. If you have any questions, please ask me. Otherwise, I'll see you in class.